Hello, my name is Jonah. I'm going to be going over my n-queen solution for this problem. So we start off with part 1, that is position index-based board representation. Here we have a definition for creating a random sample, 8 random numbers. Here are our numbers, 1, 2, 3, 4, 5, 6, 7, 8. And then here we have a definition for showing the grid. We're setting our toolbox right here, and then setting our toolbox to our array. So that way we can actually print our array, we see the numbers inside of there. And then we also can use show grid to show the position of those numbers as x's in this array. So here we are going to evaluate the fitness, but we're not actually going to evaluate it right here. We are just defining it. We also have a way to check scene and also check duplicate. We use a integer called conflict, which will just keep track of whether or not we have seen this queen before, and then we can also check to see whether or not we have duplicate queens in our array. So we're going to register evaluate right here, and then register everything else too for toolbox. And here, for the first time, we are going to create our generation, Hall of Fame, and then also launch the genetic algorithm. So we can see min starting off at 10, 15, 10, jumps up just a little bit, goes to 6, and then hits the ground at 3 and just kind of levels out. So we plot the average and min right here, and you can see the average in blue and the min in yellow. So following the min go 10 to 15, and then falling back down to 10 to 6, and then eventually falling down to 3 around 38, maybe 35 generations. So printing out our best, we get anyone with 3, which looks a little like this. Some of the queens are actually threatening each other, so this score isn't perfect, but that's the reason we have 2 parts to the solution, so that way we can test the row index-based board representation as well. So that's what we do. So we set our toolbox right here. We set it to individual. We also have numbers 1 through 7 in here, so you can see duplicate numbers, and we will take care of that. We have definition for show grid again. We're going to go ahead and register our toolbox, and then assign it to our array, and then now this is what it looks like. And then we can show grid too and see what that looks like right here. And then we're going to go ahead and evaluate the fitness again by defining it. It's a little bit different for the row index-based representation, so we don't have to check for our duplicates, because we're going to be working from the top to the bottom and working down from row after row. We register the toolbox, and then here we are evaluating, creating our generation, Hall of Fame, and then running the algorithm. Start at 2, comes down to 1, and pretty much flattens out immediately. And you'll be able to see that right away, pretty much right here at what seems to be like 10 generations. We already pretty much found our minimum, and you can see that with the average too flattening out here. Printing out our best, it's just anyone with 1. As you can see, it works down row by row, placing a queen in each row and column, so none of them are threatening each other. And this has what could be described as a perfect fitness on this problem. Okay, thank you for watching.